Good morning, students. Today, the topic which I am going to discuss is data reduction strategies. What do you mean by data reduction? Data reduction means obtain a reduced representation of the data set that is much smaller in volume, but it produces the same result. Okay, why data reduction? A database or data warehouse may store terabytes of data, that means large volumes of data. If you can use the data as it is, then the algorithm or the technique will take more time to process it and produce the results. Then automatically, it efficiency is very less. So that's why we have to reduce the data. Complex data analysis may take very long time to run on the complete data set. Okay, the reduction strategies are data cube aggregation, attribute subset selection, dimensionality reduction. In the dimensionality reduction, we have to remove the unimportant attributes. The techniques are wavelet transforms and the principal component analysis (PCA). And the fourth data reduction strategy is numerosity reduction. That is also known as called directly. You can call it as data reduction. You can use regression techniques and log linear models and histograms, clustering and sampling methods we are going to use in this numerosity reduction. Data cube aggregation. Aggregation operations are applied to the data in the construction of data cube. The lowest level of the data cube is called as base cuboid. In this one, we are going to aggregate the data for an individual entity of interest. For example, for a customer, what is the customer data? What is the sales data? Like that. Next, a cube at the highest level of abstraction is called as apex cuboid. Example, total sales in the company. Okay, year-wise or quarterly or hourly, like that. Okay, and multiple levels of aggregation in the data cubes. That is, we are going to reduce further the size of the data to deal with. Okay, so multiple levels of aggregation can also be done on the data cubes. Then reference appropriate levels. We have to use smallest representation which is enough to solve the task. Queries regarding aggregated information should be answered using data cube when possible. And here the example of data aggregation, we constructing cube. Okay, here see, year in the year 2002, what are the sales in a particular All India Electronics Company? In quarter one, first 3 months, the sales values dollar $224. Quarter two, $408. Like that, quarter one, quarter two, quarter three, quarter four, the sales are given here, and this is aggregated like here 2002, quarter Q1 plus Q2 plus Q3 plus Q4. The value will be shown here. Then in 2003, if you go back second data chart, in the same way 2003, all the 4 quarters data values data will be stored here, and 2004 likewise the data will be aggregated like that. Okay, and the right side, the data cube for this one. Here, item type which are sold or which are sold. Okay, that is home entertainment in each branch. Okay, that is nothing but the item which are sold in each branch. The items are home entertainment 568, computers 750, phone 150, and security related 50, 2002. Like that we can represent. This is called data aggregation by cube. Okay, then second one is attribute subset selection. Irrelevant, weakly relevant or redundant attributes or dimensions may be detected and removed. Redundant attributes duplicate much or all of the information contained in one or more other attributes. Example, purchase price of a product and the amount of sales tax paid. Okay, then second one, irrelevant attributes. The first one is redundant attributes, irrelevant attributes which are not relevant. Irrelevant means which are not relevant. Contain know information that is useful for a data mining task at hand. Example, student ID is often irrelevant to the task of predicting student information data mining process. That is okay. And heuristic search in attribute selection. Typical heuristic attribute selection methods are used, that is stepwise forward selection. In this one, the first one is forward selection. The procedure starts with an empty set of attributes as the reduced set. The best of the original attributes is determined and added to the reduced set. At each subsequent iteration or step, the best of the remaining original attributes are added to the set. This is the forward selection. And backward selection, this is backward elimination. The procedure starts with the full set of attributes. At each step, it removes the worst attributes remaining in the set. Okay, combination of forward selection and backward elimination. At each step, the procedure selects the best attributes and removes the worst from among the remaining attributes. Okay, then decision tree induction. Okay, it is one of the technique. Decision tree induction constructs a flowchart-like structure where each internal node denotes a test on an attribute. Each branch corresponds to an outcome of the test, and each external leaf node uh, denotes a class prediction. At each node, the algorithm chooses the best attribute to partition the data into individual classes. This is example. For example, take this decision tree induction here. Here, first one is forward selection. Initial set is given A1, A2, A3, A4, A5, A6 like that. Initial set is empty and this is a flower process. First, you have to take A1. This is forward selection. A1, I have to keep in this one. Then A2, or A3, A4, like that, which is relevant. You have to keep like this. So, reduced attribute set, that is A1, A4, A6. Then backward elimination. Initial attribute set is this is the set A1, A2, A3, A4, A5, A6. Then elimination, which is relevant you have to keep, which is not relevant you have to avoid. So by doing that operation, backward elimination step, I can get A1, A4, A6 here. So initial reduced set, attribute set is this one here. How to do induction to induction? Okay, here class 1, class 2, again class 1, class 2. Here take A4. If it is apply the label here A4, if it is yes, A1, if it is no, A6, like that. Okay, again A1 is yes, go to the class 1. A1 is no, go to the class 2. Like that we can do. This is called decision tree induction. Okay. Then dimensional reduction. How to do the dimensionality reduction? Dimensions. Curse of dimensionality. When dimensionality increases, data becomes increasingly sparse. Density and distance between points, which is critical to clustering, outlier analysis becomes less meaningful. So the possible combination of subspaces will grow exponentially. This is the curse of dimensionality. Dimensional reduction. Avoid the curse of dimensionality and also help in eliminating irrelevant features, and it reduces the size also, and it reduces the time and space required in data mining, and it allows easier visualization. Dimensionality reduction techniques are wavelet transforms, principal component analysis. So here wavelet transformation, if you see this diagram here, see it decomposes the signal into different frequency subbands applicable to n-dimensional signals. Data are transformed to preserve relative distance between the objects at different levels of resolution, and it allows natural clusters to become more distinguishable and used for image compression. Here, this is the images and the actual image and the compression in different levels. So here wavelet transform we have to use where discrete wavelet transform for linear signal processing and multi-resolution analysis. These are techniques in image processing. Compressed approximation store only a small fraction of the strongest of the wavelet coefficients. Is similar to discrete Fourier transform, but better lossy compression localized in space. Okay, the method is here. Length L must be an integer power of 2, padding with zeros. when necessary. Each transform has two functions, smoothing and difference we have to do, applies to pairs of data, resulting in two set of data of length L by 2, applies to the length. Okay, so we have to do one problem on this one so that we can understand. I will explain the problem in the next session. Okay, I will stop here. Thank you.